Thank you, both Richard and Angus, for inviting me to talk about my favourite topic, which is the little beasts that with shells that wander around in the waters of many of the rivers in Australia. The topic of my talk is life in the slow lane, and I think you'll see why as I get into the talk. I'm going to introduce this iconic element of the in-stream fauna of the Cooper, and discuss some of the unique elements of its biology. And I think we've heard an awful lot about how the Cooper is special, how it's different. It's a Boombust ecology. It's a distributary system. All of the elements that make the Cooper special in those regards are recognised and reflected in the biology of the biota that lives in the Cooper. And so there are special elements of that biology that come together with the broader physical attributes of the Cooper and make it a really special place. And I think you'll see that the particular animal I'm going to talk about is an example of that. It's a small piece, I think, in the overall jigsaw panorama, which is the Cooper, but I'd like to outline some of its needs so that we can factor those into our thinking and run parallels with other organisms and ourselves in terms of what's needed. Sorry. Going to hit the wrong... Yeah, hit the wrong one. Yeah. Okay, so the animal I'm going to talk about is this turtle. It's Emmett's turtle, or the Cooper River turtle. It's a subspecies named after Angus there, and he's lodged the largest animal in the Queensland Museum. And I guess it's a bit of a surprise that a river turtle like this would be found out in a desert river. It's you'd expect one of the species that has a better interaction between water and land and can handle wetting and drying to be out here, but instead we've got a river turtle which specialises on permanent water. It's a very large species, one of Australia's largest species of freshwater turtle, and you can imagine that the first people to walk these lands would have certainly had a great interest in capturing and eating this species of turtle. I'd love to hear some stories about that if anyone has some traditional stories about the use by the Aboriginal people of this area of this particular species. So very large, and I'll give a little bit of a talk about why they're so large. And they're also super abundant, and I mean super abundant. If you go to Ulberti Waterhole on Tanbar Station, we've done population estimates of the turtles in that waterhole and estimated that there are 80,000 very large turtles in that waterhole. We've pulled up traps and we've got the record for Australia of 96 turtles in one trap setting, in one trap, and they're all big. So, nearly pulled the boat over. Of course not. Of course not. Yeah, no. We marked them and let them go. It would have made a good meal, a good feast for a lot of people, but we didn't do that. So anyway, they're also extremely abundant, and it makes you wonder as to how they can sustain such abundances in permanent waterholes, which for most of the time are relatively low in production. And of course, we all know the answer, or part of the answer to why that's so. They're widely distributed through the system. Basically everywhere we went, they were in abundance. We also found them in the lower reaches of the Diamantina. So some of them got round. So what's their secret? And really the secret is their ability to draw upon the Boombust ecology. So you have some species like that are highly mobile. The birds, they move out of the system when the system is in its shutdown period. When you get those episodic flows coming through and there's a boom period, they move back in. You've got species of fish and presumably a lot of small mammals that just have a population crash, and when the good times come they build up again. But these animals here, they just wait it out. They've got low metabolic rate. They sit in these water holes and they wait for the boom periods. And I'm hoping to demonstrate that to you. So let's take why they're so large first. I guess the typical turtle energetics is that when the turtles are little, they bring all their energy in and they churn it all into growth. So they're trying to get through that vulnerable stage of being small to being as big as they can and to become reproductive as quickly as they can. So churn it all into growth. But the minute they hit maturity, all the energy that's surplus to maintenance gets channeled into reproduction. So they bundle out as many eggs as they can each year, often 2 or 3 clutches a year, large number of eggs, and there's a lot of mortality on those eggs, and a couple of animals survive to replenish the population. And what suffers is growth. So most turtles stop growing when they hit maturity because they're redirecting all their energy into reproduction. But when you've got a system like the Cooper, where you've got these periods of dry that are punctuated by episodic flooding, we've seen lots of photographs of this in the last couple of days, you couldn't imagine a more transformational situation for a freshwater species like a turtle than what you see between those two photographs. And so there are these boom periods. And there are mini booms when the rivers flow. So as Stuart showed, the rivers flow. It's not all episodic floods. You get these river flows, and the turtles, you can see all the little heads there, where they're waiting for the influx of new opportunity in terms of food and stuff, and that carries them through the dry period. So these low flows and the influx of food and nutrients important to them in terms of just keeping ticking over during those bust periods. But in the boom periods, both when the floods come and they move out onto the floodplains and forage, and also afterwards when there's a concentration of all of the breeding of the fish and the crayfish concentrates into the water holes, that's when you get the real boom for these turtles. It's sort of after you get the boom for all the invertebrates and fish species that you get the boom for the turtles. And here's an example of crayfish that have been concentrated in the water holes after the floods have started to recede. And I don't know if you can see it there, but we're really talking about concentrations of crayfish. These photos are taken by someone from the ABC in South Australia, I think. So real concentrations. Of course, the turtles are like pigs in mud. Like, I mean, they can just feed and feed and feed on carrion, dead fish, on crayfish, on all of the things that concentrate in those water holes and build up their nutrients so that they can start pumping up the eggs and so that they can rely on those energy resources to carry them through those dry periods. So we're talking about an animal that is really drawing on those boom periods in order to sustain itself through the poorer periods. So what happens here is that really when there's food, there's so much food that it's in super abundance. And so what this species is doing is it's throwing its per capita resources into maintenance, and there's a massive surplus, so it throws it into both reproduction and growth. So they just keep growing post maturity, and they get bigger and bigger until they're super large individuals. So basically, the special thing about these turtles in terms of their size is derived from the special features of the Cooper and that Boombust ecology that we all know is so important for all aspects of life in the Cooper. So very big. The second question comes as to why they're so abundant, and we started looking at this in terms of looking at different water holes in relation to the drawdown. And Tanbar waterhole, the Homestead waterhole, dried in 1983, and all the turtles perished because they can't really survive a complete drawdown. And then you've got places like Broadwater, which dried into shallow fragmented pools, which would have impacted on the population, but maybe not extinguished it. And then you've got populations in Springfield Homestead and Ulberti, where it's never dried. And so you've got these different water holes, and you have a look at the attributes of the turtles in them. And so basically, in Tanbar Homestead, which dried in 1983, you've got what's really an early successional stage of recovery. And so when you look at the number of juveniles to adults, you find the population's dominated by juveniles, and it's on a recovery phase of the population, and you can sort of see see how that's going to move over time if that waterhole doesn't drain again to a more climax state. If you look at Broadwater, you find it's a sort of a halfway house where the adults and juveniles are around about present in equal number, and then you go to the Unviersity waterhole, which is never dried, and you see a really climax state for the population that's dominated by adults, very few juveniles coming through, very low growth rates, very high population densities. This is the waterhole that had 80,000 turtles in it. So you've got this, you can see a successional stage, series of stages that would occur in the context of population drawdown. One of the other things that was really interesting from this is that they have compensatory mechanisms for springing back when the population's decimated. And so here we're looking at the growth rates of turtles in Tanbar, shown with the blue line there, right the way through to the growth rates of turtles in Unviersity, which is the green line. And basically the turtles in Tanbar would reach sexual maturity after 10 years. So they're compensating for the fact that the population's been drawn down, whereas turtles in Unviersity wouldn't mature until they're about 24 years old. So when the population is decimated and drawn down, there's more per capita resources. The animals grow faster through to maturity and start replenishing the population much quicker than they would be doing in the permanent the waterholes that never dry down. Those density figures are interesting. Look at Unviersity there, 231 turtles per 100 metres. So that's about, if you took both banks into account, it's about one big turtle every metre. So you wouldn't really want to be diving in off the banks of the Unviersity waterhole, because you really run a risk of clobbering yourself on a turtle. Absolutely amazing abundances. And of course unsustainable if that waterhole just stayed that way. It's unsustainable. It's the Boombust that's driving those high numbers, and these compensatory responses. Now, in terms of spatial dynamics, the animals seem to know their environment pretty well. So up around Angus's area there, the animals move between Broadwater and Fishhole and Waterloo, and they move when the river runs. They don't wait for the big floods, and they seem to know where they're going, because Sandy Kidd tells a story of where he was driving through his paddock, and the waterfront was coming through the paddock, and there was a turtle walking in front of the waterfront. So it was really anticipating that the floods would carry it through to where it wanted to go. And so they have this response where they'll move through the landscape in order to take advantage of where they think they can get the best resources, and they know their landscape well. So their home range is extending across more than one waterhole. So quite interesting, interesting biology. And that ability to move around is particularly important when you get catastrophic busts. So up at Lake Dunn dried up, and basically hundreds of turtles would have perished if it hadn't been for the local landholders picking them up and transporting them to permanent water. A very unusual event, drawdown right down to drying, and the turtles perish. And there's a bit of a spectacular picture from Western Queensland, not in the Cooper, but gives you an example of what can happen, a devastating drawdown and death of all these turtles. So the ability to move around means that they've got the capacity to do what Stuart was talking about, where you have local extinction and re-invasion. And so you have a dynamic across the landscape of populations blinking out and then being re-invaded, rapid recovery because of the compensatory growth, and then going through that successional stage to back towards the climax state. So you have that dynamic going across the landscape, but in slow motion. So we're really talking about a dynamic that would happen over many decades rather than what we might be used to in terms of meta-population dynamics of short-lived species. So they're really chasing their tails. They're ever so slowly moving from one waterhole to another. As local extinction occurs, they re-invade, build up in that waterhole, and then the waterhole that they might have come from might ultimately go extinct, and so there's this dynamic going on in a very slow time frame, which I think assists them in persisting in what would otherwise be a very hostile environment for freshwater turtles. There are other threats, and I guess the cane toad is certainly knocking about the second species of freshwater turtle in the Cooper. It only gets down to about Lake Dunn. But also, I guess, some of the illicit practices in relation to setting nets and crab pots can have devastating effects on populations of turtles. And this recalcitrant individual here that's holding up a crab pot and his little tinny for taking the net across a river, whose identity is obscured for obvious reasons, can potentially have a serious impact on some waterholes. So, but really, it's the flows and the flow regimes that are really important to the persistence of this species in the Cooper. They're important because this boom-bust ecology is integral to many species' ability to thrive and survive, including this turtle. And we're not just talking about the big flows, we're talking about the smaller flows as well that help sustain them in their densities in the waterholes of the Cooper. It's important because it allows movement of aquatic species across the desert landscape to drive this dynamic that I've talked about. And it's not just the turtles that do that, quite a few of the fish do it as well. And I'd also like to point out that the frequency, timing and magnitude of flows that are so important in the Murray-Darling Basin, to those considerations we need to add also the spatial distribution of flows as important drivers. And in my question to Stuart, I was getting at the idea that in the Cooper, where you've got that really low relief, where the water flows isn't just dictated by the channel physiography, it's dictated by the water head. In really low relief, you can't predict easily where the water's going to flow, and relatively small changes within a catchment can dramatically change who gets the water. And that matters, I guess, to the pastoralists as much as it matters to the turtles. And so that's an important consideration is the spatial distribution of flows in addition to frequency, timing and magnitude. So I guess we're all concerned about what changes might be wrought upon the system by both mining and irrigation. And so are our ponderous friends here, I guess for similar reasons, though they probably can't articulate them. And I might leave it there. Thank you.